An aeroplane can fly at 500 kilometers per hour in still air. There is a wind blowing from the northwest at 50 kilometers per hour. Jasper sets a course of 0, 30 degrees. Find the velocity vector for the aeroplane. So if I take a north line just here, then what Jasper has done is he set a course in this direction. And we know that that's 500 and that this is 30 degrees. We have a wind that's blowing from the northwest, so it's blowing down this way at 50. And if it's coming from the northwest, this angle here is 45 degrees. If we do that, this angle would be 60 degrees. And that leaves us with an angle in between here. So 60 and 45 is 105. So that would leave us with 75 degrees in between. And what the aeroplane will actually be doing is this, which is the sum of the two vectors. So we need both v, and if we can find the angle theta, we can give the bearing. So to get v, we're going to use the cosine rule. So minus 2 times 500 times 50 times cos 75 degrees. And so we can find v. So we've got 500 squared add 50 squared minus 2 times 500 times 50 times the cosine of 75, and we want to square root that answer. So that's 489. So 489 kilometers per hour. And now that we have that, so this is 489, although I use a more accurate value when I do the calculation. So I get sine theta divided by 50 would be equal to sine 75 divided by the answer we just found. So sine theta is going to be 50 times sine 75 divided by 489. So we want the inverse sine of 50 multiplied by sine 75, and we'll divide that by the last answer. I can just drag that in there like so, close the bracket, and that gives me 5.66 degrees. I'll say that's approximately 6 degrees because when we give bearings we usually give it to the nearest whole number, and so the bearing would be 036 degrees. That's 30, add the theta. If instead Jasper must fly on a bearing of 030, what bearing should he set to achieve this? So, well, let's put a north line down here. And now he must end up going on a bearing of 030, so he's got to end up going like this. So that's 30 degrees. So this has got to be the resultant. Now we know the wind is coming in this direction, and we know that that's 50, and this angle here is 45. And so he's going to have to set a course here. So this is the course he set, so this is the 500. And what we really need to know is this angle here, which I'll call phi, because that's going to enable us to give the bearing. We'll just take phi away from 30. So what can we figure out from here? So we know this angle is 30. So this angle here must be 60, and if that's a right angle, this one's 30. That angle there is 45. So those two together make 75, which means this angle here is 105 degrees. Okay, so we've got sine phi divided by 50 has to be equal to sine 105 divided by 500. So sine phi is going to be 50 times sine 105 over 500. And then we've got phi equals. So we're going to do the inverse sine of 50 multiplied by sine 105. And we'll divide that by 500. And that gives me 5.54, which again we'll do as approximately 6. And then that means we're on a bearing of 024 degrees.